Hello, and thank you everyone for joining the webinar today. We're going to give folks another moment to log in. We'll be starting soon. All right, let's get started. Hello, everyone, and welcome to the 2023-2024 Better Buildings webinar series, dedicated to bringing you the latest actionable insights from leading industry experts. This annual series is a chance to explore topics, technologies, and trends that affect your organization, as well as efforts to accelerate decarbonization and energy efficiency adoption. Today's webinar is called the Not So Shocking Shift Towards Industrial Electrification. Before we dive in, there are a few housekeeping points I would like to cover. Please note today's webinar is recorded and archived on the Better Buildings Solution Center. We will follow up when today's recordings and slides are made available. Next, attendees are in listen-only mode, meaning your microphones are muted. If you experience any audio or visual issues throughout the webinar, please send us a message in the Q&A box located on the Zoom panel. Next slide. My name is Kiran Thirumaran, and I'm your moderator. I'm a research staff at Oak Ridge National Lab. I've been here for around 8 years now, and I help support DOE in the Better Buildings and Better Plants program. My background is in engineering, and I work on things related to industrial electrification, water, and energy efficiency. Next. So today's agenda, next slide, please. Yeah. So today's agenda will start with an overview for industrial electrification. We have a few welcome polls that we would like to go through to get to know our participants better. And then we will be having our speakers. We have 3 speakers today from industries who are going to be giving really good insights on some of the technologies that they are looking at their facilities. And then we'll have a Q&A session followed by some concluding slides. Next slide, please. So industrial electrification, electrification is essentially the shift from any non-electric source of energy to electric source at the point of final consumption. The graph I'm showing here to the right of your screen is the total energy used in the manufacturing space in the US, right? So this is the data from MECS, Manufacturing Energy Consumption Survey, collected by the EIA. And what we are seeing here is kind of like a breakdown of where energy is used in the industrial sector, right? So out of the total of like 14 quads of energy, which is around like 14,000 trillion BTUs of energy, a significant portion of that is used for process heating, right? So that is like your drying equipment, your furnaces, to used in the manufacturing sector to manufacture the product. So around like almost like 9,000 trillion BTU of energy is used for that. So more than like 50% of the manufacturing energy use is used for process heating. An interesting thing to note there is, again, what we see is less than 5% of that energy used for process heating is currently being served by electricity, meaning like almost like 95% is fuel fired, right? So which is like natural gas, coal, coke. So those are the energy sources that are used for process heating in industries. So this speaks to this speaks to the potential for electrification in the manufacturing sector. And similarly, even if you look at the facility HVAC, which is shown on the right end of your screen, we have around much less energy use, around like 1,000 trillion BTUs of energy use, and a significant portion of that is still like fuel fired, right? So both in the process heating space and in the building HVAC side, heating, ventilation, and air conditioning, there is scope for electrification within the manufacturing sector in the US. So this is what we are going to be looking at. So our speakers are going to be talking a bit more about these things. Where are they finding opportunities on the HVAC side? Where are they finding opportunities on the process heating side to electrify these processes? Next slide. So whenever we speak about electrification, we also need to consider the grid as well, because any process that we do electrify needs to be served by the grid, and having a renewable source of energy powering that grid is important. But fortunately, our grid is getting greener by the day, and any forecast that you take, this one is a very conservative forecast given to us from a EIA. It projects almost like 55% of the energy by 2050 is going to be coming just from solar and wind, right? So a lot of integration of renewable is going on. And in parallel, if we electrify, we can get much of the decarbonization benefits that comes with electrification. Next slide. And of course, decarbonization is one of the big drivers for electrification, but it is not the only reason that we would electrify our processes, right? There is productivity benefits that comes with electrification, product quality benefits, and also benefits associated with operating cost as well. And these are things that we'll be hearing more from our speakers today. Next slide. So before we get to our speakers, a few items. So today we'll be using interactive platform, the Slido platform for question and answer, and also for polling. You could go to slido.com on your mobile device or on a new window on your browser and put in the event code DOE and to get into the platform. If you would like to ask our panelists questions, please submit it anytime during the presentation, and we'll be getting to those towards the end of the presentations. And also, if you find a question that you like, you could like vote it up so that it kind of like rises to the top of the queue. Next slide. So we would like to know more about you. So let's start off with a few polls. Please join us over at Slido to respond to the following questions. If you have any issues, please message our tech support on the Zoom Q&A. So the first question we have is, what sector best describes your organization? You could go ahead and hit your whichever is relevant to you and hit submit. Wonderful. So we have a lot of participation from industries. And quite a few of us joining from the consulting world and also from the utilities and the state governments. Fantastic. Thank you so much. So next question. Yes. So the second question we have is, what are the electrification opportunities most relevant to your facilities, right? And of course, if you're not from a specific facility, what are the opportunities that you're seeing in this space with respect to electrification? All right, we see the options jumping around a little bit, starting to settle. So implementation of heat pumps, 40% of you are seeing a lot of opportunities there. And of course, within DOE is spending a lot of resources on the heat pump side of things, developing new technologies, pushing pushing the envelope and also in implementing them. We also see quite a bit of people choose electrification of process heating systems. So that is your gas-fired furnaces, dryers, and also implementing other electric HVAC systems, right, outside of heat pumps, resistive air and water heating. So we do have a couple of projects that our speakers have going to be talking about some of those opportunities. Fantastic. Thank you so much. All right, so we will get into the core of the presentation webinar today. So we have a great lineup of presenters today. So we have Dee Sporalik from Volvo Group Trucks, Rollis Reisner from McVane, and Edwin Wilhite from Schneider Electric. Thank you all for being with us today. So our first presenter is Dee Sporalik from Volvo Group Trucks. Dee is an environmental, energy, and sustainability engineer who has been with Volvo Group Trucks for 8 years. She holds a BS in Integrated Science and Technologies and a master's in Energy Systems Engineering. Dee's expertise lies in navigating environmental regulations as well as supporting energy reduction and decarbonization projects. Additionally, Dee is an active board member of our local AEE and CWEEL chapters, showcasing leadership and passion for energy and sustainability. And with that, I will hand it off to Dee to kick us off.
Thank you so much, Karen. All right, welcome everybody. I'm really happy to be here to talk to you about electrification opportunities at Volvo Powertrain in Hagerstown, Maryland. So I'm the environmental, energy, and sustainability engineer here, and we manufacture the powertrain, which is the engine, axles, and transmissions for Mack and Volvo Class 8 trucks. Next slide. So just a quick breakdown of what we're going to be looking at here and what our scope is. At our site, we have all renewable energy certificates that cover anything that isn't renewable for our electricity. So when it comes to our CO2 reduction goals, we're going to specifically be looking at natural gas, which is the biggest piece of the pie, and diesel. So for natural gas, that's really going to be our hot water boilers and our heat treating. So I'll be focusing on those two things today. Next slide. So before we get into that, I did want to touch on the fact that we have 2 solar systems on our site. One is a north parking solar canopy, which is a 1.32 megawatt system. And another is a ground mount system that's about 2.2 megawatts. So combined, this does provide about 14% of our on-site electricity usage from renewables. But more importantly, it also reduces our peak demand by almost 50%. And that's really important when it comes for electrification to ensure that we have enough capacity on the grid. Next slide. We also have a number of regenerative dynamometers on our research and development side. So our facility is split between operations and GTT, which is Group Trucks Technology. And on the technology side, we do have engines that are running constantly for testing, right? But they're not actually powering anything. So as we've been retrofitting these test cells, we have been adding regenerative dynos to them so that they can produce electricity and that energy isn't just wasted as heat. So they provide almost or over 50% of the electricity required from our technology side of the campus. Next slide. So as I mentioned before, 90% of our CO2 usage is coming from natural gas from our operations side. And most of that is coming from these 4 hot water boilers that we have on site. So these boilers are through, they heat the building primarily, mostly through a primary loop that goes to a heat exchanger for secondary loops. And there are a couple processes that are tied to this. But as you can see, these are pretty big. So we have done a case study at a different facility with a much smaller, a 2.5 MMBTU boiler to see how that changed. And that allowed us to kind of create a case study of what it would look like for our boilers here. Now, the problem is that these boilers aren't really at end of life yet. We still have maybe 8 to 10 years on them. So it's kind of that balancing act of, do we do that now just to meet our goal, or do we look more at the whole life cycle of the unit? Next slide. Excuse me. So here was our initial analysis, not looking at first costs here, just operating costs and how that would change. So if we wanted to reduce our CO2 emissions by 30%, we could replace 2 out of 4 of those boilers. That would reduce our CO2 emissions by about 3,000 metric tons. But specifically, if we're looking at replacing these with electric boilers, that cost is going to increase quite a bit simply because natural gas is just cheaper than electricity. So as you can see on the right, it would increase our operating costs annually by about $500,000 just to replace 2 of those boilers. So again, this is not something we have completely ruled out, but we do want to make sure that the business case is there. Next slide. In addition to operating costs, it's really important to make sure you're seeing the whole picture. And demand costs are something that can really make or break a business case. So it's really important to ensure that you're looking at that as well. So just as an example, this is how it would look for our peak demand. Every electric utility is different, so you have to look at your bill and see how your demand bills are structured. But for us, our current on-peak annual cost for demand is about $469,000. And then if we were to replace 2 of those boilers and move them to electric, we would be looking at about $780,000. 4 of them, $1.5 million. So again, this is something we've kind of placed on hold, and we said, okay, great, we have this information. What can we do beyond this to maybe reduce the load from the boiler so that down the road, when they are ready to be replaced, we're only replacing 1 or 2 rather than having to replace 4 and have these very high costs. Next slide. Next slide. Yeah, there you go. Thank you. Okay, so for example, our next step was saying, what can we do to reduce that load from the boilers? Most of the consumption is coming from space heating, but we do have a couple processes on it, such as our engine oil heaters or specific washers we have. So our engine oil heaters use the natural gas boiler loop. And because the oil needs to be heated to 140 degrees Fahrenheit, that means we have to keep the boilers at 183 degrees set point all year round. So if we can just remove this process that really doesn't take that much energy from the loop, then we could reduce that set point. Reducing the set point isn't going to result in a whole lot of savings. There will definitely be some transmission losses that are avoided. But really the benefit here is that we can now look at other technologies that don't have to go up as high as 180 degrees Fahrenheit. So I know heat pumps are a really hot topic right now, and there's a lot of new technology that's coming out for that. But the struggle is that temperature, that high temperature that they need to get to. So I'm seeing some in the range of 140 to 160, not really 180. So doing something like this could help us open up for different types of electrification technology. So in this process, right now it's being heated kind of far away. It's staying heated constantly. So we are taking this opportunity to look at a tankless heating system and heat right at the source. And that would allow us to save energy as well, rather than just shifting to electric. Okay, next slide. So our other big process that uses natural gas is our heat treating furnace. We have one you can see in the bottom right here that was purchased kind of right before we made these CO2 reduction targets. So this one is completely natural gas. Now this is a carburizing furnace, so it also requires RX gas to be able to create the atmosphere that it needs. But going forward, we also have been looking at getting a second one of these furnaces. So not even a CO2 reduction, but just avoidance of CO2. We need to look at some some other alternative rather than a fully natural gas furnace. So the two options we were looking at, one is an all-electric. Of course, this would use resistance heating. We would still need to use some natural gas for the RX gas, which is what creates the atmosphere, but there is some opportunity to possibly use hydrogen or a different low-carbon fuel in the future for that. Another option we looked into is a possible hybrid. And the reason why is because these furnaces have to get up to 1700 degrees Fahrenheit. But once they're up there, they usually stay there. We're constantly producing. It doesn't make sense to cool it down and bring it back up. It ends up using way more energy that way. So the big concern is, how are those demand costs going to look if we need to ramp it up to temperature quickly, all with electricity? And so that's what that cost comparison is down there. It's still a lot less than the boilers, but it's, you know, it's a hefty chunk of change. Now, we did decide to go with an all-electric option. And one of the ways that we're going to try to mitigate that demand cost is to have that ramp up time go over 24 hours rather than over 2 to 3 hours. So the plan would be that we wouldn't have to have that spike in demand that would then, you know, possibly determine our demand costs for the whole year. Next slide. So when it comes to heat treating, there are multiple types of ways that you can heat treat. The one before was a carburizing furnace, but we also have induction hardening on site for our crankshafts. And induction hardening is all electric, and it's a really great technology. So it's definitely something, before you're considering which one to do, to first look at induction hardening, because if you can make it work, it's much better in the long run. So the benefits is that electricity is being put exactly where the metal needs to be treated. So you don't have to heat a whole, all this air that surrounds the parts themselves. So that really increases the energy efficiency. Also, because of that, it will improve precision and process control, and you can therefore do even higher production rates. There are some cons to this and considerations. If you have a process that needs multiple parts, all sorts of different parts, it really is only meant for one type of part. So for example, in our heat treat furnace, we did look at induction hardening, but it just wasn't cost effective because we would need so many different parts and processes to go through. So something to look at, because it can really make a big difference. Next slide. All right, so a couple final thoughts here. Remember that every application is different, every facility is going to be different, but the first step, if you haven't yet, is to really understand your facility's heat loads and when they occur, and see how you can quantify and maybe work together and reduce things here to be able to reduce it there. For electrification, electrical infrastructure is really important to understand early. Right, there's going to be restraints. You may not have a lot of demand even available, so you got to work with your utility to understand that. They might even, if you're adding a lot of stuff to the grid, they might want to do some load studies. So that would be a really good time to make sure those are in the pipeline so that you can be ready when you want to do those electrification projects. Work with your utility, because there are so many rebates and incentives out there. Here in Maryland, there's a really great program which we pay into every month as part of our electric bill, and then we can get rebates out of that. So if you're not taking advantage of that, I really encourage you to do that, because otherwise you might be leaving a lot of money on the table to help these business cases. Also, consider, as I mentioned through this, make sure you're considering not only operating costs, but also demand costs. Really important to have the full picture along with your first costs. And then utilize heat recovery whenever possible. Our furnace that we have, there's a lot of heat that's being wasted from that. So one of the projects we have is to possibly do some heat recovery from the stack where it's being put out, and possibly inject it into boiler loop lines so that we can have hotter water going through the facility. So that's where you can kind of start thinking outside the box. And that's all I have for you today. Thank you so much.
Yeah, thank you so much, Dee. And just as a quick reminder, we are taking the questions on slido.com. I do see a couple of really good questions come in. We'll be getting to those towards the end of the presentations. So our next speaker is Rollis Reisner. Rollis is the past Chief Information Officer at McWane Incorporated, where he currently serves as the Assistant Vice President overseeing legal, health, and safety software platforms. McWane is a leading manufacturer of ductile iron pipes, fire hydrants, and fittings, one of the world's leading manufacturer of waterwork infrastructure. McWane is also a top producer of ductile iron poles, steel fabricated tanks, vessels, fire extinguishers, and fire suppression systems. With that, I will pass it on to Rod.
Thank you, Karen. Thank you for inviting me and volunteering me to present this morning. Look forward to sharing some of the initiatives we have going on at one of our divisions, Tyler Union at McWane. And you did a good job of telling, next slide, please, of introducing our company. I'll just add a few items. We are indeed one of the world's largest manufacturers of waterworks infrastructure. We're located in Birmingham, Alabama, and we have facilities around the globe. We have over $2 billion in annual revenue. Most of our melting and manufacturing facilities utilize natural gas-fired cupolas. And in Tyler Union, in particular, in Anniston, Alabama, they manufacture ductile iron fittings for the waterworks industry, and they have over 500 employees. The facility produces a broad range of ductile iron fittings, which connect ductile iron pipes and are a critical component to our nation's water infrastructure. Unlike Volvo, you won't be riding on any of our products or inside of our products, but we bring clean water to your home and we take water away, and we take care of safety and compliance as well. Currently, our facility utilizes a scrap melting cupola and requires a significant usage of non-renewable resources, as you would imagine. They emit a variety of air emissions, including greenhouse gases. The cupola furnace utilizes significant amounts of coke and natural gas as fuels to produce molten iron, while the air emissions are controlled by high-efficiency fabric bag houses, which you may have seen. Significant quantities of GHGs are emitted. And this is what indeed has led us to look at electrification. Next slide. I have very few pictures, but this is a picture of a cupola on the right. That's one of our cupolas at Tyler Union, very large. You can see lots of systems going to power this engine or this core in order to melt the iron. On the left, you can see this is one of our smaller melting facilities where the iron is charged in the cupola and then comes out, and then this iron is then taken and either spun into pipe or is then made into various different molds. The process uses scrap metal. Our ductile iron products are over 98% recycled content. So we start with a very high bar from our recycling content. We charge the cupola with coke, raw material, and other ingredients that we do call our secret recipe in order to make ductile iron. Next slide. We know the following, right? We have two projects currently in Anniston. One is a new product line where we are installing an electric melt oven. In doing so, we decided to evaluate changing the natural gas cupola as well. And as many of you know, making the decision in a boardroom is pretty simple, but in theory, it's very complicated in delivery. It's a bit like remodeling a house rather than starting from scratch. Next slide. So what does it mean to go from a cupola to induction melting? We had several opportunities here, and I'll explain some of our challenges later. But one was, of course, gathering some data. So some facts that help push our decision to convert. In a particular month in 2022, Tyler Union, again in Anniston, Alabama, melted over 4,000 tons of material with afterburner usage of approximately 2,400 MMBTUs. The proposed project would replace the existing cupola furnace with electric induction furnaces, significantly reducing the amount of GHG emissions by eliminating the use of coke and natural gas at a cost of over $18 million a year. In an example, for Scope 1 emissions, in 2022, we reported from the current cupola operation over 27,000 metric tons of greenhouse gases, with the use of coke contributing around 22,000 and natural gas contributing nearly 5,000 metric tons. Since electric induction furnaces, as you may be aware, do not use coke or afterburners, there will be a significant reduction in greenhouse gas emissions by nearly 91%. So that's a pretty easy case there to make, right? Let's look at this on a per scale basis. We look at per ton when we look at managing and measuring our production. Our current operation in Tyler Union emits about 0.47 metric tons, or 1,000 pounds of greenhouse gas emissions per ton of iron that we melt. Whereas if we transition to electric induction furnace, it's remarkable. Our operations would emit an estimated 0.043, or only 95 pounds. So that's going from 1,036 pounds to 94.8 pounds of greenhouse gas emissions per ton melted. Now, in doing this, I know you're asking, what about Scope 2 and Scope 3 emissions? Because adding Scope 2, of course, emissions when we start electrifying our plant, we estimated Tyler Union's annual Scope 2 emissions in 2022 to be around 19,000 metric tons. Now, power consumption would increase to manage the electric induction furnaces, but by eliminating multiple large motors and other outdated equipment needed for the cupola furnace, the proposed project could offset the power consumption needs for electric induction furnaces, bringing us potentially to a zero increase in Scope 2 emissions. So that's pretty amazing when you really put pen to paper and start figuring this out. Now, for Scope 3 emissions, we anticipate a significant reduction in raw material utilized and waste generated, and in the process of reduction in the storage and transportation of these materials. So by eliminating and significantly reducing raw materials like coke, limestone, lime, silicon, and oxygen, and EnviroBlend, which is part of our recipe, there will be a reduction in greenhouse gas emissions at multiple suppliers' facilities. So we believe that we've proven there would be a reduction there as well. A lot of this data we pulled together because we asked for a tax credit to help support this, which I'll tell you about shortly. So looking at a project timeline and cost, Tyler Union estimated that the project would take about 23 months and from design to completion in 3 phases. Phase 1, we were looking at 6 months for project design and engineering. Phase 2, placing purchase orders. There's around a 12-month lead right now that we found for electric induction furnaces. And then Phase 3 would take around 4 months in order to place all the equipment and bring it into production. Next slide, please. So how did we look at managing the project from a cost perspective, right? We looked at the Advanced Energy 48C credit program. I don't know if many of you are familiar with this program. We applied for the credit to use to help us fund this conversion. And it's a federal incentive for investments in advanced energy products that A, reduce greenhouse gas emissions, B, increase domestic production of clean energy products and materials, and lastly, create high quality jobs. The credit is equal to 30% of the qualified investment for eligible projects that meet certain requirements. The requirements are stringent. The program was established by the American Recovery and Reinvestment Act of 2009, and then was recharged this last year with a $10 billion investment under the Inflation Reduction Act of 2022. The Department of Energy and the IRS are responsible for certifying and allocating the credits to the applicants. And the application deadline in this process was last year, December 26, 2023, but we are anticipating applications reopening again this year. Fortunately, after all that work, we crammed together at the end of the year. We did have a successful concept paper that was submitted, and we were invited to apply. But at this time, since we have these two dual projects going on with the new induction furnace, we decided to stall this project, go ahead and put in the new induction furnace, and then come back afterward. Next slide. And that brings me to the challenges that we saw. And part of those challenges you just heard in us slow rolling this project a bit. Challenges first, garnering executive support, a hurdle for the project. The idea is running the cupola is something we've done for 100 years. And it wasn't the wolf that was eating us now, if you've ever heard of that analogy. The wolf eating us was issues with coming back from COVID, with maintaining a proper employee base and making sure they were trained. It was scrap, right? The last thing we want to do is produce more scrap. I know that we do recycle scrap, but if we're making scrap, then we're not making good product. So those things were hindering our opportunity to move forward with the project. Time to install, taking a month or more to install the electric induction furnaces, interfering with production, essentially stopping production when we're running, full bore right now, and also the costs and time of our team and distractions. Changing the operation mode, this was significant, and this is where we're going to learn more with our new induction furnace, right? Shifting from continuous supply, which you may understand from a cupola, we can continuously pour our scrap and our recipe into the cupola and have a continuous flow. This is not true in a induction furnace. You have batch operation. This requires adjusting production planning, logistics, and of course, quality control. One of the last items is improving the scrap quality. The induction furnaces operation cannot cope with poor scrap grades. This because of the electromagnetic field creates coupling of the recipe, and so you have to make sure that your scrap is a lot cleaner and scrubbed before you introduce it into the heating process. And then investing in a new technology, which is going to require new team members or a lot of training as well, and it's more capital intensive. There's more maintenance involved, more maintenance costs. However, in the long run, there's a significant savings, but it does take years to return that investment. Then lastly, challenges for applying the 48C tax credit. Again, if anyone is interested in our procedures and how we went through this, please reach out to me. I would be glad to share. The competition for the funding is intense, and the timeline for us was tight. We only had a few weeks to pull together a lot of data. We had an immense amount of data, but the IRS requires that you distill this down to a very limited few pages so that they can get through the process quickly. The applicants have to meet certain eligibility and technical requirements for qualifying the project, such as commercial viability, timely project lines, specific greenhouse gas emission impacts, supply chain growth and resilience, and then workforce and community engagement was really critical. In fact, that's one of the items where they came back to us and said, look, we like your process, we like your application, but we do think we should see you spend a little more time on how this is going to affect workforce and community engagement. And additionally, the applicants must comply with prevailing wage and apprenticeship rules for construction, alteration, or repair of eligible property, which we do. That's all I have.
Wonderful. Thank you, Rod. A quick reminder to our audience to send in any questions you have to slido.com. The event code to get in, it would be DOE. And we'll be answering those questions right after this presentation. So for our final speaker, we have Edwin Wilhite. Edwin is employed by Schneider Electric as a regional facility leader. He manages the facility operations for 8 facilities in Tennessee, North Carolina, and South Carolina. He's a subject matter and supply chain Edison expert for energy within Schneider Electric North America. These responsibilities include supply and demand side energy management and energy reporting for the organization. Over to you, Edwin.
Thank you. Thank you. Let's just get right into it. A couple of years ago, next slide, please. A couple of years ago, Schneider set a very aggressive goal. And the goal said for operation scope 1 and 2, which is what we'll be talking about today, we're going to be carbon neutral by the year 2030. Net zero ready means that that we will buy offsets to take care of electricity, and we will be out of the gas business in all of our operation by the year 2030. Quite a big goal, a goal that it took a long time to communicate and get buy-in, and we're still getting the ball rolling. It's in all of our sites in North America, over 50 or 60 sites, and as we roll that forward, it's a big elephant. And today we're going to talk about just one bite of that elephant. If you go to the next slide, please. We've got a long history with our energy program, which started in the year 2005. We've worked for a year-over-year energy reduction goal every year since then. We have been great partners. We've had a great partner in the Better Buildings program with the Department of Energy, and we appreciate that. We're now on our third iteration of goals pledged for the Better Plants. We're excited for that, and we're looking forward to another 20% of energy efficiency in the next few years. Next slide, please. What are we doing and how are we doing that? Our energy efficiency program, the first thing that we do, and I guess what we're most comfortable with, is energy efficiency. And we're continuing to invest. The easiest and best way to reduce carbon is not to produce it, to not need it. So we're looking and we're investing heavily in continuing our energy efficiency program. Electrification is we're transitioning away from the use of fossil fuels, and we are converting those we're electrifying those processes. And then last, we are sourcing our electricity from renewables. And I think we have further goals down the road to take that even further. Next slide, please. So what does that mean? Inside our facilities, it means that we've got to eliminate all of our natural gas that operates the facility. That's from HVAC, boilers, hot water heaters, stovetops in our cafeterias, ovens, everything that would have today uses electricity, we have to convert. We have an electrification goal for our processes, which would include paint lines, preheat ovens, cure ovens, our plating processes. And we have the challenge to convert those from natural gas to electricity as well. It's kind of funny, up until just a couple of years ago, we were still installing gas. When our company made the commitment, it was turning a switch, and then we were all in for electrification. Next slide, please. So the step that we're doing today, in our Columbia, South Carolina site, we had a old boiler, and part of the boiler, it operated a cleaning process for our bus bar, large pieces of copper to conduct electricity in our switchboards. We got rid of hot water for comfort for heating of the building 5 or 6 years ago, but we didn't have a clean way to get rid of this process. You can see from the camera, from the FLIR camera, it's a very inefficient process. We were leaking heat into the building, lots of humidity in Columbia, South Carolina, to make a tough situation worse. Lots of maintenance on an antiquated boiler. And so we made a decision that we were going to eliminate that process, replace it with a very compact, very efficient electric water heating and cleaning process from GenFab. The cost of this equipment is somewhere between $300,000 and $500,000, depending on how you count taking the equipment out and cleaning up the area and that kind of thing. We're expecting it to use less than half the energy of the old process. We get rid of a boiler that was terribly oversized. We put all that equipment at point of use. We free floor space so that we can hopefully have more manufacturing to shorten lead times of electrical equipment, which ought to hit a note with everybody. And for us, it's a win. Again, it's one bite off a big elephant. And so you say, well, what's next? Next year in Columbia, we'll be replacing 5 and 6 year old rooftops with heat pumps. Next year in Columbia, next page, please. This is the next step of that process. This is the natural gas oven where those bus bars are plated and then the plating is cured. We'll be working on the technology and the process to change that process to electricity. This is going on, and we, at Schneider, we have a lot of relatively small facilities that together use a lot of energy. So we do a lot of benchmarking with each other. We find that this process works in Colombia, and then we replicate it at several other processes, several other facilities that use a similar process. So again, one step towards our goal of zero carbon. Next slide, are there questions?
All right. Yeah, thanks a lot, Edwin. Think we would move to the question and answer. So if you haven't already, please join us over at slido.com with the event code DOE to submit and upvote your questions. So yeah, so thanks a lot for your questions. We'll try to go through as much as possible within the time we have. So getting right into it. So the first question we have here is, how much do you expect electric utility demand charges to change as more facilities electrify and it becomes increasingly difficult for utilities to plan and generate the required power? So has this been a consideration for any of the organizations, an expected increase in the demand charges that could potentially be coming in the coming years?
Yeah, I mean, I think it's hard to answer this question because I'm not a utility, and I'm sure there have been studies out there. But this is why I think it's really important to make sure that you are in communication with your utility before you start actually making these changes, right? Because you could be creating a strain that creates a bigger issue. And then that's where I think the demand charges might increase quite a bit. So yeah, just keep that in mind, and your demand might increase depending on your project.
Fantastic. Thank you, Dee. And
We have regular communication with our utility. If we were a new facility coming in, green out of the ground, all that, everybody kind of knows everything when you go for permitting and that kind of thing. If I decide that I want to change 15 air conditioners on a roof and change those from gas to electricity, nobody really knows that. And the only way the utility has a way to know is for you to tell them. And if you have to bring in a bigger service or something like that, inherently your demand charges are going to go up through the price of the transformer.
Yeah, we have dedicated power on site, and we talk to the power company, consistently. So they're aware of what we're trying to do.
yeah, thank you, Rod. Thank you, Edwin. On a similar note, I think our second question is about when you go for electrification, how do you deal with the perceived increased risk of disruption, right? And your increased reliance on the grid. How do you think about those challenges?
That's definitely a concern for us, especially, for our heat treating furnace. Luckily, we have a backup right now that might eventually be hydrogen, so we could have some sort of non-electric backup. But, for really critical processes, it is important to maybe consider a UPS system or some other backup battery storage or things like that. But it is a risk, absolutely.
We have natural gas generators on site because the last thing you want is for that electric oven to go off for any period of time.
Yeah, thank you, Rod. I think there was one other question that was on a similar note. Was there like a consideration of energy storage, possibly batteries, one for resiliency and also for helping with the demand charges, right? Because you could you make use of the cheap energy available if you do have like extra storage, like an energy storage. So is like battery storage or thermal energy storage been a consideration along with any of these electrification projects?
We do have, not our site, but a different site has looked at doing large energy storage for peak load shaving. So not necessarily in tandem, but just in general. And that would also give them some extra capacity as well.
Yeah, thank you, Dee. So the next question we have is, can the speakers comment on the state of their electrical infrastructure? So transformer, substation, prior to electrification, if upgrades were required, as they were doing the electrification projects. I know, Dee, this is something that you have touched on, and Rod, you might have had these consideration as well, given your large induction projects.
We did indeed have to upgrade. I didn't include the cost in this project because we upgraded for the new facility we're putting in. And we just made sure there was enough capacity for converting eventually, but we didn't. So that would be a good project to go back and see, to what extent it costs to add the additional capacity. But sorry, I don't have an answer.
And we are doing that. We're doing studies at every one of our facilities to try to understand what the real impact will be of, if we change gas packs to heat pumps that have strip heat backup and paint lines that currently use gas to electric, it's going to affect our consumption. Our electrical infrastructure at some of our plants is old, and we are considering that a part of the project.
Yeah, Dee, did you have any additional thoughts on that?
No, just that, most of our projects that we're looking at are relatively large, right? So they have almost all had to require some level of infrastructure upgrades. So, we recently got a really great one-line diagram that shows the whole map of the electrical facility. And that helps us understand exactly where our restraints are and where we might need upgrades. And yes, if a project comes online that needs that extra substation or whatever equipment, we do incorporate that cost into part of the project.
Mm-hmm. Fantastic. So the next question we have is, when developing a case for electrification project, how do I estimate the amount of fuel purchased, consumed, such as natural gas, to its GHG equivalent? So I could take a first stab at that question. So there are GHG inventories, like specific kind of like factors, emission factors available for each of the fuel sources that is available in the US. Those are available from EIA and a bunch of different organizations that you could refer to. DOE also has tools that has incorporated some of these emission factors by region, so you could make use of those tools to find the emissions reduction that is possible from your electrification projects. I do have some of those tools in my concluding slides that I could quickly share with the participants. Does anyone else wants to chime in on that, on how you are going about calculating these emissions from these projects?
Yeah, we just use online tools, tools from you, and then also contacting, our power company.
Fantastic. All right. So I think then we'll take one more question, and maybe we could combine those. Has there been any consideration for gas turbine cogeneration or gas heat pumps? Has those technologies been considered in any of your facilities?
For us, our eventual goal is net zero. So if we're going to do an investment, we want to try to eliminate the fuel completely. Well, of course, energy efficiency first, right? But if we're going to implement a new technology, we probably aren't going to go to like a cogeneration for the investment.
What she said.
Fantastic. All right. Thank you, everyone. I think we will transition back to the slides. I know there are a couple of questions we weren't able to get to, but definitely reach out to us with your questions. You can reach out to our speakers as well. to connect offline with some of those questions. So I want to leave folks with a couple of tools that DOE Better Plants and the Better Buildings program is developing, specifically around industrial electrification, right? Next slide, please. So there are a couple of tools that we already have. We have the Measure, which is the energy modeling tool available for you free of it's all these tools again like developed by DOE. So it is paid for from the taxpayer money for you to make advantage of. So it's free and available for you to use. So the first one we have is Measure. It's an energy modeling tool. Again, like we spoke a lot about process heating systems, induction furnaces, dryers, ovens. So this tool will help you model the baseline system and find the baseline energy use and emissions from these systems. We also have a cost comparison model and Excel-based tool, which you could use to go systematically into the different cost components that would contribute to your baseline furnace systems as well as like your electrified options, right? And do kind of like a holistic cost comparison of not just the energy cost, but all the other cost components, including labor, maintenance, and everything that goes into it. So that's the thermal process cost comparison calculator. And the last one we have is Electrification for Decarbonization tool. This is an online tool. Again, you could check it out in the link available, which does that emission factor conversion, right? That I just spoke about. So depending on the location your facility is located in, it will connect to the relevant grid and the relevant grid factors and give you a comparison of if you do electrify, what would the impact on your emissions for that specific facility would be. So those are some of the tools that we already have. Next slide. But the Better Climate Challenge program, we continue to develop new tools. So one of the big things, or one of the reports we are working on, is the Electrification Assessment Framework, which is a product of a collaborative working group discussion we've had with our partners last year. And we are putting together this framework on how do you go about doing a facility level electrification assessment, right? So kind of like going through all the different topics that our speakers spoke about, kind of like starting with like evaluating your electrification infrastructure, identifying projects, identifying projects, how do you go about comparing it, and eventually implementing it, right? So the report will go through kind of like give you the steps that you could take in order to implement it. Next step, next slide. And we are also developing like complementary, supplementary tools that goes along with the framework, right? So tools for evaluating specific technologies like heat pumps, like forklifts, what would be the cost savings and the emissions reductions that comes with it. So those are tools that we continue to develop, and we'll be like publishing it and in the coming months. Next slide. So outside of these tools and resources that that are being developed by the Better Plants and the Better Buildings program, the broader DOE also has a lot of activities going on in the electrification space, from technology development, fundamental research to piloting projects, and kind of like getting it to a point where it could be commercialized, right? So again, we don't have the time to talk about all the different things that are going on in the electrification space within DOE, but I just wanted to highlight a couple of things, right? Again, a lot of these you could follow up with more information available online. The IEDO office within DOE has been putting a lot of like research funding over the last couple of years and continue to do so, right? So one of the funding announcements that came out last year is to develop technologies for decarbonizing industrial heat specifically, and with specific interest areas being industrial heat pumps, electrification of industrial heat, and also innovative low and no heat processes. So DOE continues to put in quite a bit of effort in the space to develop new technologies. Next slide. DOE has also set up the EPICS Institute, Electrified Process for Industries Without Carbon Institute. So this is going to be led by Arizona State University, and they are putting together the pieces to kickstart this institute, which would be a collaborative effort with where manufacturers and other stakeholders will be able to will be able to take part as part of the activities of the institute, again with the holistic goal of developing and implementing electrification projects and electrification technologies and take it to the next level. On a similar note, we have the next slide. The industry heat shot, which is again a department-wide effort to bring about a decarbonization of industrial heat, right? Of course, this would include not just electrification technologies, but also other technologies like hydrogen and other fuels. But thermal processes is a big consideration within this DOE-wide effort to decarbonize industrial heating processes. Next slide. So this webinar is part of the 2023-2024 Better Buildings webinar series. As we could see, we have a great lineup of presentations through March, and you could look at the other webinars that are coming up at our Better Buildings Solution Center. So the next webinar is going to be on actions for transforming climate plans into actions, and you could register for it at the Better Building Solution Center and get the information on those. So next slide. So we are pleased to announce registration for the 2024 Better Buildings, Better Plans Summit is open. The summit will be in the heart of Washington, D.C. from April 2nd to 4th. And in addition to having interactive and engaging sessions, you'll have an opportunity to network with your peers as well. You can explore the session tracks and book your accommodations on the Better Building Solution Center. Next slide. So the Better Climate Challenge Roadshow, the Cleveland edition, is here. You can watch it on the website. So you can the DOE. We have the episodes includes DOE energy experts visit several of our Better Buildings and Better Plans partners to see how these organizations are putting decarbonization strategies into action. So we have Cleveland Cliffs, City of Cleveland, and Cleveland Clinic are the participants in this roadshow. We have, and you could watch the full series on the Better Building Solution Center. Next slide. So with that, I would like to thank our panelists very much for their time. Feel free to contact our presenters directly with additional questions. We have our emails here. I also encourage you to follow the Better Buildings Initiative on LinkedIn and X for the latest news. You can find all our handles by the respective icons on the left half of the slide. You will receive an email notice when today's recording, slides, and transcripts are available on the Better Building Solution Center. Thank you, everyone.